Now let's take a look at how aromatic compounds react. So they undergo electrophilic aromatic substitution, which is abbreviated EAS, and they all follow this basic mechanism. So I'm going to use some basic symbols for the parts that are involved. So here you see we have a benzene ring, and then the reaction is going to take place at one of the carbons, so we're going to end up removing an H. So I've drawn that H in. Now, electrophilic aromatic substitution, so you know that we need an electrophile. So I'm going to draw that in with an EL. And then the first step in this mechanism is that this pair of electrons that is in the double bond with the carbon with our H, it's going to come up and it's going to attack the electrophile. Remember, electrophile has a positive charge on it because it wants electrons. Now when we do this, we end up with a few resonance structures. So the first one that I'm going to draw looks like this. So now we have our electrophile and our H on the same carbon. But now since we used electrons in this double bond to bond to the electrophile, this carbon right here now has one less bond on it. So that's why we have a positive charge there. Even though this carbon lost a bond by getting rid of this double bond, it gained bond to the electrophile, so it does not have a charge now. Then we just continue to draw in the bonds that are still there. So that is one structure. Now we can move this positive charge throughout the ring. Like if we take this double bond and move it up so that it goes vertical on this carbon-to-carbon bond, we can get the positive charge down below, and it looks like this. So you see we flipped this bond up, and that took away a bond from this bottom carbon, so now we have a positive charge. And then the last resonance structure is if we take this bond on the right side going vertical, and we flip it down to now go between these two carbons here. That will move the positive charge up to here. So there are the three resonance forms. Now the last thing that we have to do is put a base in, and this base will deprotonate the hydrogen. So we can pick either of these structures here, the first one or the third one, because the electrons from the H are going to fall down and make a double bond to the carbon that has the positive charge. So I'm going to choose the third structure. So it looks like that. And then we get our final product, which looks like this. So you can see what we've done is we've gone from a benzene and we've substituted through electrophilic aromatic substitution this hydrogen for an electrophile. So now we are going to move into some more reactions that use this mechanism, and we'll take a look at those shortly.